It's actually day 15. Let's fix it. Day 15. Yes.
Yes.
Perfect. Hello, everyone. We are back. Day 15, first day of the third week of 100 days of code with Leon Anderson. Leon, how are you doing?
I'm doing pretty good. I had a lot of fun today as well, as always. But I only had like 2 or 3 hours at max today, so I didn't go into the DOM yet. That's I'm like that would be the exact next section. So I finished everything before the DOM, but couldn't go into the DOM yet. And I did the homework you gave me. I think it might maybe make sense to start there. And we can go into what came afterwards, or what do you think?
Sounds great, yeah. So either you share your screen and we go through it on your end, or you send me the code and we'll work on it on my end.
I think it's easier if I send it to you. So copying out of Vim into other programs is sometimes a bit tricky. Here we
Amazing. So let me pull the stuff up, and in the meantime, we can listen to. Yeah. Nice. So we got it ready here. Sweet. So let's look at your map function. So we take in an array and we take in the function, and you create an empty array, and then you loop through the array for the length, and for each element in the array, you push in the function. Yeah, perfect. That's what I call naming an exercise.
Ooh. Yeah, I had result.push, and then I had in the brackets of push. At first, I wrote first element.func because I was sometimes I confuse functions with methods still. Or let's say like with the arrow functions and all these different ways of writing it, I'm sometimes like, is this now how I can write it or not? So I had to correct a little bit of syntax, but other than that, I managed. So I didn't know what the problem was with that, with like result.push brackets first element.func. So I had to consult ChatGPT, and I said I said, please give me a hint without spoiling the answer. So I had a little bit of help, but just a tiny bit. So
Nice, yeah, that's great. Prompt engineering also a very important skill. And also
yes.
with these functions, like they are literally the building blocks of everything. So that is one of the things that everyone can be super relaxed about, because you're going to encounter these things so many times that eventually you'll get the hang of what is possible and what is not possible.
Awesome.
Sweet. So what else did you do?
Okay. I went through the sum and every methods. So basically, if you do .every, it checks if every element in an array has, or I think even in an object, maybe, I don't know if it's for both objects and arrays, but it checks if every element has a certain condition, and for some, and then it returns true or false, depending on what it detects. And with the sum method, it checks basically if some of the so at least one of the elements in the array is having a certain condition that you can put in the brackets. Yeah. And then I went and looked at the reduce method, which took a little bit more time because I already looked into it a little bit yesterday, and then I started at the point where I left off, and then I had forgotten about the beginning, so I it would have I took a way bigger what's it called if you don't go to something in English?
Sorry, you broke up for just a second. What is it called? If?
Pardon?
I did not understand your question. I'm sorry.
Okay, I'll look it up in the dictionary for a moment. Detour. I did a little detour trying to find out what the reduce method, how it works, and but then I restarted the video and got some of the first points he made there, put them into context, and then the rest made sense. So I can recommend, if you start, to not start after a day in the middle of a video, at least for things like that. And yeah, the reduce method is basically it has some similarities to filter in terms of that it looks for certain conditions inside of an array or object, but it only returns one value, and there is like a pattern that it goes through. It loops over every element, and it loops over with the initial value, the current value, and the return value. No, with the accumulator value, and then like three values, and it returns what it returns. So basically what you write into return so and so, it will be the first of these values again. So basically, if you let me see what you wrote there. X stands for accumulator, I guess.
Yes.
Yes. So basically, if you want to add multiple numbers in an array and build the total sum, then you at first the accumulator is in the first round it's 0, then it's then the current value is 1, then it gets returned, then the accumulator is 1, so basically the return value from before, then the current value is 2, both get added together, and then the return value is 3. The next round of the circle, the accumulator is 3, then the current value is 3, as well, because at least if you go into through this array that we see here in the screen, then both get added into 6, and then 6 is the new return value, and the return value for the next loop becomes the accumulator, and so on and so forth. So it goes like a triangle motion, basically. And you can not only do like a sum of something, but you can also check through all different through a whole array if it has a minimum what's the minimum value or the maximum value inside, or probably other conditions as well. And it does that by basically checking, like it looks at the first one. So in the minimum value thing, you would, for example, say array.reduce brackets, then another pair of brackets to start the function. To claim the arguments of the function, the first argument, which would be the accumulator, you can then call minimum value, because that's what you're basically what you're looking for, and you're not looking for a sum in this case. And then current value, and then close the brackets, can do an arrow to what's it called? If min is smaller. No, if min is bigger than current value, and then return current value. So then the current value gets is overriding the min that we had from before. So it's checking against each element of the array if it's basically bigger or smaller than min, and if it's smaller than min, then it replaces min. I hope that made sense. Did I get that right?
It sounded correct, yeah.
Okay. Yeah, and then the final output will be the smallest it will find. It will be only one string or one number.
So a good exercise for you and for anyone else at home is to implement map and filter using reduce. So basically what you did here with the for loop, try to implement this map function and this filter function with reduce, because reduce is the most mighty array method. And I love reduce. A lot of people hate reduce because they just feel like it's very hard to learn. But in my opinion, once you understand reduce, it's so powerful and you can use it for so many use cases. And to show how powerful it is, or that it's the most powerful, one great exercise is to implement map and filter using reduce.
So you mean setting up reduce in a way where it fulfills the role of map and filter?
Basically, yeah. So the same thing that you did here, right, where you created your own map function, also create your own map function, no function map. So I'm going to comment this out to avoid the variable conflict, right? And then array and the function, and then inside of here, implement it, but use reduce for the implementation instead
inside of
the
that
for loop. Yes, exactly. So implement the map functionality, but use reduce for the implementation of the function.
Can you copy that out for me as a
Yeah,
homework,
I'll send it to you.
Awesome. Yeah, sounds interesting. That's that was fun doing that today. Yeah. And then after reduce, I looked at arrow functions in combination with this keyword. What's that on the screen?
That's the comment so that people can see the injections. It's weirdly formatted. I just wanted to try it out.
Got it. Oh yeah, I didn't. Last time we didn't talk about arrow that I learned arrow functions because we were at map and filter. So I learned arrow functions yesterday, I guess. Yeah. And I have to say that I had to look into that a little bit more because to me it was a bit confusing when to, or let's say arrow functions is basically a way to write functions in a more concise way. And there are like different levels of conciseness one can do. And since learning these, I try to or let's say sometimes I failed some coding exercises because I arbitrarily combined different levels of conciseness into each other. So I have to look again. Like, for example, in one of the levels, you have to include a return, and in some levels you don't. In some levels you have to put brackets around, in some level you don't. But also you don't have like there are different levels of conciseness, and I think you can't. What I figured out is that you can't use like the first half of the function in an unconcise way and then the second half in a concise way. At least that's how I that was in one of the how I interpreted one of the bugs I had in some of the coding exercises.
What do you mean by concise? I don't really understand what you mean by that.
So you can, for example, on the screen we can already see like the arrow function that you used up there in line 32, for example, and why are you stealing it? And as far as I know, you can there are some cases where you can even remove like the brackets around I mean, yes, around the X, you can remove the brackets around the X, as far as I know. Is that right?
Yeah, that's right. It's only that the code sandbox is configured so that it always adds them in. But in general, you can leave them out exactly if you only have one parameter.
Exactly. And then there's also, I think you can leave out the brackets at the end. No, not if it's inside of a method, I guess, right? But if it's inside of a function, then you can sometimes leave out the round brackets. Did I get that right?
Do you mean the curly brackets? These ones?
No, the curly. Oh yeah, As far as I think you can leave them out in some.
Yes, exactly. So that's just really quickly because it's not that hard. There are only 4 differences between arrow functions and function keyword. And I think once you see all 4 differences enumerated in a list, it is a lot easier for you to remember them because otherwise your brain kind of has to gather them on their own. But if someone lays them out for you, they become pretty obvious. So the first one is they have a different syntax. Right? Are you familiar with the word syntax?
Basically, like spelling or grammar, maybe.
Yeah, this was pretty obvious, right? Because it's just different way to say it. But you say the same thing because both are functions. But then there is no such thing as arrow function, declaration, only expressions. So basically, what that means is if you we talked about hoisting, right? Where we defined that function below and a different function. But we had function A right here, and then we had function B right here, and then we were able to use function B in function A, even though function B was defined below function A in the program, right? And this sentence is just the accurate way to say that is impossible with arrow function. So if you have arrow function A, let's call it C in this case, just to keep our enumeration, and then you have B, right? You cannot right here call D because D has been defined. Oh, sorry. Well, technically you can in this way, but basically D is only declared once the program gets here. So this is possible, but for a different reason. But basically because D is an expression, they need to be declared in the correct order, top down, basically. And that's just a fancy way of saying this. And then the third one is arrow functions don't get their own diff. We looked at it also a few sessions ago, right? Where we had that object and we put this into the arrow function. Suddenly it was referencing the object, whereas the real function was referencing again the window, right? If you just go, I think, 2 streams back, we have that example still, and all the recordings are still on YouTube for those that are watching. And the last one is, and that is kind of related to the first one, but you can also use arrow functions with an implicit return. So arrow functions have an implicit return. So then we can just look at quick examples for each, right? So if we say function, so let's take first example here. First one, function sum function, and I just call it function because it's a function keyword, right? So we have A, B, and then we return A plus B. And if you write the same function as an arrow function, so sum arrow, you have A, B, and then we say return A plus B. So these are the same function, just different syntax, right? So we got the first one covered, then the second one. So let's just write this here real quick, different syntax. When we have the second one, there's no such thing as an arrow function declaration, so only expressions. For that, we can basically write the example, like we have a function declaration, and that says console.log, I'm a function declaration with the keyword, with the function keyword like this. And then we have function keyword expressions, and I'm going to list them real quick first. I'm going to explain them a little bit more in depth. So if you're a little bit lost right now, don't worry. I'm going to clear up the confusion in just a second. So function expression with a keyword, you can already see. This is a const. You can already see the difference, right? A declaration just names the function, an expression assigns it to a variable. But let's keep going. Then there's no such thing as a function declaration. The arrow function. So function declaration, the arrow function doesn't exist. And then the last case, right, we're just permutating through all the different possibilities. So const arrow expression is equal to this, right? And we say console.log function expression with arrow function. So what does that basically mean? So that means we can go below all of these And we can call the declaration pretty easy. This is allowed. Let me clear the console above this so we have a clean log. Console.clear. All the stuff from above. It's not in the console, right? Function declaration, function keyword works super fine. Then if we call, what do you mean by foo? Then if we try to call a function foo that we assign afterwards using the keyword expression right here, this breaks because expressions cannot be called before they have been assigned, right? So in the example above here, that would be if we try to call keyword expression here, that doesn't work because expressions are things that we assign to variables, and because the expression is always declared after. Because when we try to call an expression and the expression has been declared after we call it, that doesn't work. We always need to declare the expression before we use it. So here this works, right? It's printing out here. And this is the example here basically. So if we try to declare something, and it doesn't matter if we use varlet or const, it's always the same. As you can see, this is always red underlined. It's always crashing. So this doesn't work. Which is, and then the next one that we have is for error functions, right? Sorry, I used an error function here, but we can also declare this as a function. So we can also say function with this, same spiel, we cannot call it. And that is basically the difference between the four. So since error functions always have to be assigned to a variable as an expression like this, we always have to define them first before we can call them. And that is the second rule. And the third one is they don't get their own diff. And by the way, feel free to interrupt me if you have a question, right? Otherwise, I'm going to just keep really quick to go. I'm going to just quickly go through this. The third one is no diff. So that basically means if we have an object, right? And it's like a car and it has 4 wheels. And then we say yellow wheels. So a function that should basically return the amount of wheels up to uppercase maybe. And then we do a separate one, the error function that we call count wheels. And we say return this dot wheels, right? And now we say car dot yellow wheels. And that's console.log bed, console log. And this will log out 4 as we see here. And we say console.log car dot count wheels. It's count wheels. It's crashing because this is undefined. So if you're trying to say undefined dot wheels, that's obviously crashing. And so crashing. So let's comment this out, right? So because functions do not give their own this is pointing to nothing, it's crashing. And then the fourth rule is error functions can have an implicit return. So for implicit return, and implicit return just basically means we can leave out the return keyword. And leave out the return keyword if what is being returned is also an expression. It's an expression. So an expression is basically anything that JavaScript can evaluate and assign to a variable. Expression can be evaluated and assigned to a variable. So basically, if we have something like this, const if arrow, and we say a, b, and then we say if a bigger than b, then we return a, otherwise we return b. So maybe we call this function like is the like maximum, right? We get the maximum of the two values. This is a statement if. So if cannot be assigned to return to implicit return. But did you already have the ternary operator? Do you already know what this means?
No.
The colon. Okay. It's a way to write if conditions as an expression. But the plus, for example, right? Plus the plus operator is and then having stuff before and after the plus operator. This is an expression. So the function that we have above here, the sum error function, we can also write this one using an implicit return. So we can also write some error implicit return is equal to a b and then a plus b. So we can leave out all of this stuff where we have a function body with the curly brackets, and we can leave the return keyword out, and we can just return the result immediately, because this is an expression, so this can be validated immediately, and then this means it can be returned immediately. And it's called implicit return because it's implied that basically this is around it, right? But we can leave it out, so it's an implicit return. It's implied that this gets returned.
And because if an if statement is
This is a statement. Statements cannot be assigned to a variable, right? You can say const my variable is equal to if b, right? That's not valid.
Yeah, makes no sense.
Yeah, and therefore it cannot be an implicit return. Only things that can be, that's just a rule of thumb. As a rule of thumb, if it can be assigned to a variable, then you can probably make it an implicit return.
So loops can probably also not be assigned an implicit return.
Exactly. For a loop, you also always need a function body. So you need the curly brackets.
Yes, it is.
And then like some details that are left out above here, right, where we talked about the different syntax. There's like the special case. If you have only one argument, you can leave out the parentheses. I don't know if that's the correct spelling, but basically, let's say you have something like a function double, right, that takes in x, and then returns x times 2. This is valid. If I'm saving now, code sandbox will add parentheses around this x, but this is technically valid JavaScript. Maybe I can make it stop. Let's see. Maybe I can say just ignore x line or something. This maybe. No, I don't know how to stop code sandbox from doing this, but let's write it as a comment. So this is technically valid.
Yeah. And I mixed some of these dynamics. I mixed them up, and then stuff didn't work. So I have to so he showed us map, then arrow functions, and then filter, and like after arrow functions, like after showing arrow functions, he used sometimes arrow functions, sometimes declared functions, and it got a bit confusing to understand concepts like filter with the new syntax, and so that was a little much at once.
Yeah, makes total sense. But yeah, just keep going at it, and if you have any questions, you can always bring it up.
Yes. Yeah. So we looked at filters already. The timeout and set timeout and set interval. I would have to look it up again. I didn't remember the exact syntax for that. I know that this exists, and it's basically kind of a nested function, or a function inside of a function, but I don't know the exact syntax by heart, and I guess as soon as I will use it, I will look it up again, because so far there was no use case afterwards. Are these used often, or?
No, they are used often enough, but I have memorized them by now. So they do come up a little bit, but totally fine. You know that it exists. You know how to look it up. That's all you need.
Yes, yes. And also with the help of ChatGPT, I realized that I probably don't need the formula collection that I was starting.
Well, it's good that you have it in your mind, right? Because ChatGPT is only as good as you can prompt it. So if you
Yeah,
don't
yeah,
even
yeah.
know what to ask it for, it might not give you the right thing. And also, like,
Yes,
keep
yes,
in
yes.
mind, like, ChatGPT is great. Everyone should use it as their little cheap private teacher. But at the same time, like an explanation like this around the differences, ChatGPT would probably not be able to generate reliably. You probably have to ask it many questions, many follow-up questions, and it would not be possible for it right now to just concisely summarize stuff like this. But it's perfect to answer like little questions, to help debug things. Like, everyone should definitely use it.
Yes. Yeah. And then, yeah, like some of the dynamics of arrow functions in this, I think there was a dynamic that, but I was also like that I know where to look it up in the course approximately, and that should be enough. Like there was some special case where you can use this and arrow functions, and which doesn't work with normal declared functions, but it was the kind of a special case. Do you know what I mean?
Yeah, so this article, I'm going to put it in the chat for everyone. I can highly recommend it. And I'm also going to send it to you. I'm
Mm-hmm.
going to make it big. So this is a great article to really internalize how this works. There's even like a quiz in it, a game, but obviously you can only play that quiz once. So what I recommend is, if you want to really understand this, read up on it and then test yourself by playing the game of this article. And then you will see how that you will know it, right? But I think I also mentioned it when we first came across this keyword. It is a very complicated keyword that is hard to understand what it really points to at different times. And luckily, you will not come across it often. So I would just, take your time right now while learning with it to try to understand it as best as you can, and then just leave it behind. And when you come across it at it again, you can use Google and ChatGPT and Stack Overflow to fix the problem when you are facing the problem in the moment that you face it.
Yes, yes, and knowing where approximately this came in the course is also helpful to see a little bit of the context and to then better prompt ChatGPT.
Yes.
Okay, so then today I worked through the next section of some newer JavaScript features. Default parameters, basically that if you have a function with predefined parameters, you can set an equal sign after one, and then a default value to make sure that if it's not filled, like for example, if you use it as an expression without filling the brackets, then you still get a return. So for example, in a dice roll function, you can set the value of how many sides the dice has as a parameter, and if you don't put it in, so for example, if you want a 20-sided dice for example, to play Dungeons and Dragons, then you can put that in. But if you leave it blank, you can it will default to 6 of the regular dice, because you predefined it with an equal 6. So inside of the brackets, while declaring the function, you can write, for example, num sides equal 6.
Yes. It would be great if you ever want to code your own Dungeons and Dragons software. But I also want to point out real quick, if as soon as you have a default value, you need the parentheses again. So
Yes.
this right here would not be valid. You need them basically for any case, other than it's only literally a single value, you need the parentheses.
Okay, but it doesn't have to be declared as a function, right? It can also be defined as an expression and as an arrow function instead. To use that.
To use what?
Pardon? To use default parameters.
Yeah, default parameters work with both the function keyword and arrow functions. And not just with arrow functions, you can leave out the parentheses if you do not use, I just wanted to clarify, because you said, you don't know when you can leave out the parentheses, right?
And I know that. I know. Those parentheses I know, but like the curly brackets sometimes and stuff, like when to leave them out. That was
you will come across that so many times. You will eventually develop a feeling for it. So just take a relaxed attitude towards it. It will be super fine.
Yes. Exactly. And okay, that I had a question about the default parameters, which was that if you have multiple parameters and you assign default parameters to one of them, you have to put them, as far as I remember, you have to put them as the last of the parameters while defining the function, because then if or as the first. Wait a second. No, yeah, exactly, as the last, because if you type in the first few, if you type in the parameters that don't have any defaults, then they get filled up by they get the input that you put in assigned, and those who you want to leave out, because they have a default value, you can just leave them out at the end, basically. That's the basic dynamic. Did I get that right?
Yes. So here it's important to point out that it is valid JavaScript to write this, right? But if you only put in one value, then the second value will still be undefined. So we say like console.log, multiple defaults, and I put in a 1, right? Then it gives me not the number, because it puts in the 1 here, and this one's undefined, so it calculates 1 plus undefined, which is not a number. So while it is valid JavaScript, it just doesn't make sense to do it.
Yes, like it's kind of a user experience thought.
Yes.
Coder experience.
Did you already look at Destructuring?
Yes.
Okay.
But I have a short question before that. Would it be possible to write how was it? To put in comma 1 into the console.log multiple defaults?
No, that's crashing.
Okay, I thought then that the first one would go to the default then. Okay, got it.
No, that is possible with arrays and destructuring, but it's not possible when you call a function.
Okay. Yeah.
You had the structuring the array side.
Yes, but first spread.
Got it.
Spread, rest, and then destructuring. Spread is basically spread in function calls. What was that again? I remember spread in arrays and in objects, but what was it in function calls? Wow. Let me open that up real quick. It's if you want to put in the individual elements of an array as arguments into a function. Then you can't just post you can't just put in the array in some points, but like the array variable name. But what you can do is ... and then the array variable name, and then it, instead of putting in the array as a whole, basically it puts in each element after another of the array. Did I get that right?
Yes. So let's see. You can have a collect argument, for example, and you put them all into an array, and then you print out the array, right? And then you can just collect the arguments. So you can say console.load, collect argument of like 1, 2, 10, right? And it gives us an array of all the arguments.
Yeah, but you have to have an array defined before, right?
No.
I think this is different than spread, what you showed there.
This is basically spreading the arguments from a function. That was the first one that you mentioned, right? Function spread. I thought that you were there. So
function calls, spread in function calls.
Yes, exactly. That is the example for spread in function calls right here.
Okay. I think Cole uses a different use case. He basically says if you have a function that you want to put in multiple arguments which stem from a spread, which stem from a
okay. So what Cole means is probably this. So you could say const my numbers equals to 1 and 2, and then we had our add function above, right, where we take it sum or sum function, right, where it takes a and b. So we can say const my sum or my result of summation, just to keep the variable name somewhat unique, is sum of my numbers. You mean this, right?
Exactly.
Now it is add a got it. Okay, yeah, that's I guess the other way to put it. Yeah. Oh, here, this is basically, you can say, you can pass to this function as many arguments as you want, and they get converted to an array, right here. And this is basically, the function takes in a certain amount of arguments, and we can just take an array, and each element of the array will be put to each argument of the function.
Why? I don't understand the first, like the array to array thing. How? Because if you put in multiple elements, like what happens with the array variable, like with the r? R
is the name. So basically,
what happens with the name? If the name doesn't get input, okay. So the whole, it's not ... comma R, but it's dot 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 R as a whole.
Yes, it basically
Okay.
says spread means give me all the arguments and turn them into an array, and then R means call this array R. So if I put the function body here, for example, this is
If you
more
say
R, and I could say
return,
stuff like R push, 423, and then I return R, and then we get 23 also in it. So R is basically the name that the array where you connect the arguments has for the scope of the function.
and there is an implicit return at the end of this, right?
Doesn't need to be. So you can, because this is an array, and just returning a variable is an expression, right? Because we can say const my thing equals to an array. That is possible. Therefore, you can leave out the curly brackets, but you can also write it like this: return R, right? Or the
Okay,
example that we had before when we said R.push, I don't know, like 42, right? And then return the array.
But if we do R.push 42, we would have to. Can we, where the 42 is, could we put in dot 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 R as well?
What do you mean? Could we put in dot 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 R?
Into where into the brackets where the 42 is now.
Here.
Yes. Can we write? Does that make sense?
Yeah. Then we get 1 to 10, 1 to 10, right? Because when you call it like this, we take the arguments and spread them in, so we get 1 to 10, 1 to 10, and now we have the area of 1 to 10, 1 to 10 here, and we say, hey, into this area of 1 to 10 or 1 to 10, also push 1, 2, and 10 again, which is basically what we do here.
And if you delete the return R,
then this returns nothing, and nothing happens, because array only lives inside of the scope of this, right? So it's just a variable that gets created, only lives in the scope of this. We do something with it, but that doesn't matter. We return nothing, so we return undefined.
Got it. Okay, and yeah, cool. That's interesting. Like there are, like, to me at this point, there are like so many different use cases, but no or rarely any use cases that I can apply real world use cases yet. So it's, to me, it's very abstract, like so many different isolated functions that I'm like, okay, cool, another one. Okay, cool, another one. Okay, but I'm curious of how they will be applied, but I guess that's coming soon.
So right now, it's fine if you just in your mind collect them all mentally. Yes. And then we laid out the general curriculum before. I don't know if we did it on stream, right? But after you finish the course, you're going to build just something. So you have built your first own thing, like just a small thing, just to basically solidify all the skills that you've acquired in the Code Steel course. And then afterwards, we're going to go through a whole new curriculum. And in this curriculum, you will basically master all these techniques, because you will get tasks that are basically pure logical tasks. To solve these logical tasks in an elegant way, you will need to use all the stuff that you learn here. And obviously, when it comes to that, either you're going to get hints, right, or you can ask and stuff to recall, okay, which one of these do I need to bring up, or maybe you're going to have an inclination and then just pick some stuff and try stuff out. But what I'm trying to say is, don't worry about like having to remember these, because you will be confronted over the course of these 100 days of code with them again for sure.
Yes.
And then you're going to be able to put them into a meaningful context.
Yes. Yeah, it's just always funny when you show me something new, and then it's like, okay, cool, another one. It's like, okay, it's like always the same reaction of mine. But yeah, that's always.
I mean, keep in mind, he's basically showing you most of the language, at least the 20 or not in 20%, the 60% of the language, I would say, are covered in the course, and it's the last 40% or so, they barely get used.
Okay, yeah, that's awesome. Yeah, I'm almost I'm over a third now of the course, getting quite close to half of the course by now. So
yes.
Yeah, so and the next things were spread with array literal. What was that again?
The thing is, I don't know how in how much detail we want to go through this because
yeah, exactly,
we're already
exactly,
streaming
exactly.
for 1.5 hours almost. So I think we should call it a day, Phil.
For 1 hour, as soon as I. But
1 hour now. Yeah, exactly.
yeah, but yeah, I agree. Yeah, basically, like the destructuring is, maybe I can summarize it short. I try to summarize it shortly. It's basically to you can. It's basically you're flipping like defining a variable on its head. You're starting with const, and then you're using brackets of different different elements of that are inside of arrays or inside of objects, and then you equal to a new array, and then this is basically, I don't know if I got that right, but yeah, I guess it's to. Are you writing examples of it? Oh yeah, destruction. Object destructuring objects. Object. Console log. Oh, I have no idea about comma.
We mentioned that earlier, right? Do you remember where we talked about the default values, and you asked, can I do multiple defaults, comma or second? And I told you that's not possible when calling a function, but it's possible when destructuring arrays. So basically what we say here, right? So first of all, this is a deeply nested object, right? Where we have a key foo and a value bar, and then we have another key crux, and it contains an object with a key hello and the value world, and another key nested. And then nested, I just called it because the object is nested. And then numbers is our numbers array from way above. If the people remember or just tuning in or whatever, 1, 2, 3, 4, 5, 6 is the content of the numbers array, right? And here, what we did first is we took the numbers array and we destructured the first 3 numbers. So 1, 2, and 3. So when we log that out, here we have 1, 1, 2, 2, 3, 3, right? And then and I put it into an object just because it's easier than having to write like console log 1, 1, right? This is also like a neat way if you want to use console log. If you just put an object and then you have the name of each variable with each value in the console log. But basically, we have another key nested that contains the array of numbers. And now we're destructuring first the full key. So we have the destructuring basically says from the object, take the key that we are destructuring and create a new variable with its value. So basically what's happening here is the equivalent to const foo equals bar. And now the foo is available in our space. But you can also do that in a nested way. You can also say if you have a nested object, right, where we have a key that contains another object, which basically means nesting. Nesting is if you have objects with an object. Then we can say, hey, from this key, hello, take the key, from this key crux, take the key hello, and this is basically the equivalent of saying const hello equals to world. And then we can go even more nested because here we have an array. And now we can go to the array and we can grab names from the array. So let me comment this out for a second. So we could take, for example, the first value of the array, 1, and now this would be the equivalent of, say, const 1 equals to 1, but because, wait, why is it crying? Maybe I've declared 1 somewhere else. So let me remove the 1 just to not get the errors here. Basically, it's just because of the semicolon. Yeah, that makes sense. So we can put this again. So const 1 equals to 1. And this is basically taking the first value of the nested array. But I want to deliberately put this away and put this in again. We can also just ignore the value by putting in a comma. So first value, we ignore it. Second value, we ignore it. Third value, we ignore it. Fourth value, we want to grab that. So we write in a name for the variable. And this is basically now the equivalent to const 4 equals 4. Because 4 is the fourth value in our numbers array up here. If we put in, for example, 2 here, then down here, 4 would now be 2. The value that's contained in the array.
Okay, that I guess it was a bit too complex for me. This quick. I'm not really seeing the use case. Like, what is the output of that?
Basically, this stuff that it's written in the comment. So the code that we say there is the equivalent of saying const foo equals bar, const hello equals world, and const 4 equals 4. And here right now, you don't really see the use case, but in the real world, there are tons of use cases for destructuring. So I can show you one use case. So a use case can be, like right here, we have 2 values, right? And we want to assign the default value to 1. But in order for this to make sense, we would have to flip the order, as we saw earlier, right? We would have to get the second value first and the first value second. But there's something that other languages have, which is called named parameters, right? If you remember, a parameter are the names of the variables in functions, right? If we had a function, my function would accept the parameter, that's what it's called. Even though we could call it literally anything, we could call it like center, clause, or whatever. But that is basically what a parameter is, right? And in a language like Python, you can do something like parameter, I don't know, and then you call it JSON, right? And then in this function, you could reference JSON as the name. So you can basically give the parameter a name. In JavaScript, you cannot do this directly, but what you can do is you can leverage destructuring to basically get name parameters. So what does it mean? It sounds complicated, but it's not. So basically, you can just say const my function equal to, and then we destructure an object, and we could say first and second, and then we return maybe first plus second. So if we call this function console.log, my function with an object, for example, first is 41 and second is 1. If we say my function first 41 and second is 1, right? Then the result is 42, because we destructure first from the object and we destructure second from the object, and then we get and then we add those here, and that's what this function returns, right? And what we can do now is we can give this a default value of I don't know, let's say 0, right? And then we remove this here. Now it still works, because this has now a default value of 0 in the destructuring. And we can say 0 plus 1 is 1, which is the exact result that we get here.
Okay.
So basically, destructuring can be used to accept arguments and functions and to give them names, first of all. So now this is a certain name, but you can also then assign it default values, and you don't need to put in all the values. There is a lot more that there's a big benefit of like API design with this one, but that's a topic for in 2 to 3 months. But now the important thing is, even if we go through these things a little too quickly, right? You're like, oh, I don't know if I understand this, or then you're like, oh, I cannot see a use case for this yet. The only important thing is that your brain gets a little bit exposure to it, and it's all about pattern recognition. And if you then are confronted with this pattern in the real world, you recognize it, and through repetition, 2, 3, 10 times, you will eventually get it. So trust that, because programming works like a language, right? And every human, no matter how smart or dumb, most people can talk, right? You have to be really stupid to not be able to talk. And this language module that is just given to you by birth. And programming languages are nothing else than a language. So eventually you can trust your language module to pick up the syntax. You still have to think through the logic of the sentences to make sense of them. You still have to think through the logic of the program to understand what the program does. But in terms of, what is written here? What does it really do? You can just trust that continued exposure will train the language model in your brain to recognize these patterns, and you will eventually understand them, and eventually they will become second nature to you.
Yeah, that makes sense. Like, like grammar and vocabularies, knowing all of that, and then I only have to think about the logic of the content that I'm describing with the words.
Yes, but here's an important point, right? While it helps you to consciously understand these things so you can learn them faster, right? There's a reason why a child takes, I don't know, like maybe 15 years to properly talk, right? A 5-year-old can talk, but a 15-year-old still has meaningful improvement over a 5-year-old in the way that a 50-year-old expresses themselves, right? So the reason why it takes someone so long to acquire a language is because they cannot rely yet on their logical brain to have them acquire the language faster. So understanding the rules of the grammar of programming will make it so that you can understand these things faster and learn them faster. However, it is important that, technically speaking, your language module will eventually learn these things either way. Because when you were a child, no one told you, this is a genitive, this is a noun, this is a verb, right? These rules exist, but you were just talked to by your parents, by other children, and you eventually understood implicitly what a noun is. And there are people who can talk and who use nouns correctly in sentences, but they might not know what an adjective or a noun is, simply because they don't remember the stuff that they learned in school, right? So we can develop an implicit understanding for these things, even if we cannot express them. We can still use, like, a native speaker who has no school education is probably still able to talk correctly, use correct grammar in 95 to 98% of their sentences, maybe even 200% of their sentences, and they can detect a sentence that doesn't make sense in terms of grammar without consciously understanding the grammar. And that is a big point about programming. Being able to logically understand these things gives you a huge advantage in terms of learning them fast. But at the same time, you can approach programming with a relaxed approach, because eventually the grammar module in your brain that is native to us, but to all of us humans, will take care of it and learn these things for you.
That's awesome. That's some meta learning inside. That's good. That's great.
Yes.
Yeah. Thank you.
Cool. I think that is a great note to end on. Usually in the end, I always give like a little inspiring speech, but I think that counts as the inspiring speech. So as anyone who's learning programming, just trust your language model in your brain. You learned a way harder language than JavaScript, because if you understand this stream, and you better do this, listen to this while you watch this, then you probably know English. And English is more complex than programming, because every word that we use while programming is an English word. English word, right? Function is an English word. Map is an English word. Plus and minus, you could argue, okay, plus, minus, division, and multiplication are things that you need to understand from math, right? But the rest is just English. So if you understand English, you've already learned a language that is way harder than JavaScript. It is very easy for you to learn JavaScript. So just put in a few minutes every day, few hours every day, put in whatever time you have, and eventually you will learn this language and you will be able to build great stuff with it. So that is the end of the 15th day of the code call with
Leon Anderson, who puts multiple days into a day. No, just kidding. Leon Anderson and my mentor,
Alice Mill, who gets also multiple days worth of work done in a single day. Take care everyone, bye.
Bye bye.